What does it look like to apply topology optimization to a 3D printed spine implant? You'll see it in this episode of the Cool Parts Show.
I'm Pete Zielinski.
And I'm Stephanie Hendrickson.
We're with ADDITIVE and this is the Cool Parts Show.
This is the second episode of our new series where we talk about cool parts 3D printed by viewers like you.
All right, challenge on you. Your turn to bring a cool part. What do you got?
All right, so Pete, I'm sure you've seen 3D printed implants before. I'm thinking specifically of implants for the spine. What do those usually look like?
So when they're 3D printed, spine implants, not solid, but more the form has a mesh, a lattice structure for bone ingrowth.
Right, so what I brought today is a spine implant. It's 3D printed, it has a lattice structure, but it has a lattice that's unlike any that I've seen before.
Yeah, so I'm used to like a regular lattice geometry, a honeycomb or like a checkerboard, but this is a crazy purple bird's nest, right? Like what's going on here?
Right, so this implant was 3D printed by Tangible Solutions in Beaver Creek, Ohio, using powder bed fusion. It's made of titanium, and this could be the direction that lattices are going in the future.
All right.
So I'm going to let Chris Collins, the Chief Operating Officer at Tangible, talk a little bit about what they do and why lattices are so important to their business.
Tangible Solutions makes 3D printed titanium orthopedic implants. That's 100% of our business. That's all we do. About 90 to 95% of that are spine implants. Lattices are valuable to spinal implants because they can reduce the global stiffness of the device. And so in particular in spine implants, it's very important to make the stiffness of the implant as close to the disc as possible. With additive and lattice, you can use the lattice to tune the stiffness of the device to lower it and bring it closer to what an intervertebral disc would be. Lattice in spine implants also aids bone graft volume, so that'll enable the surgeon to pack the device with a larger amount of bone graft, which can decrease patient recovery times and improve bony ingrowth into the device.
This is more like what I think of as lattices, and even this one would be hard to model, I think, but it's at least geometrically regular. That's not what this is. This is just craziness and no consistency. Like, you gotta talk me through the crazy.
So it's crazy because it was topology optimized for the loads that an implant like this would be expected to bear. So Tangible used software from nTopology to optimize the directions of the struts, the width of the struts, and even the build angle to make sure that this would print the way that they expected it to. And as a result, they're able to design this implant with the lattice that's specifically designed to serve this one particular purpose.
Why is it purple?
So I'm glad you asked. It's purple because it's anodized titanium, and you might want to do that just to differentiate between different sizes of implants or maybe just for aesthetics. But the fact that it's anodized and it's made of titanium is sort of interesting because usually when we talk about titanium implants, they look something like this. It's a solid piece of metal. But the issue with putting something like this into your body is that this solid titanium is a lot stronger and stiffer than your natural bone. And so as your body heals around it, your bone can actually kind of get lazy because it's depending on this really strong piece of metal. That's why a lot of implants now are made out of this plastic called PEEK because it's a little bit less stiff, it's a little bit closer to the natural characteristics of your bone. However, when you topology optimize and 3D print a titanium implant like this, you can actually adjust the stiffness. And so you end up with something that's a lot closer to your natural bone that your body can then heal around, and you don't end up with that sort of laziness in your spine.
All right, so that's a lot. Let me see if I got that. With topology optimization software as part of the design, you could put the lattices to work for you. You can get the strength that you want precisely. You can get the flexibility, stiffness that you want. by applying that to the software and letting the software create the lattice form no matter how crazy it is to give exactly those structural properties. And then you can get that in addition to the other reasons you use lattices, which in the case of an implant is the area for bone to grow into, anchor the bone better, and speed recovery time. Is that right?
Right, exactly. And so this is a really specific use case in a really specific industry. It's not even something that necessarily is going into bodies yet. But you can see how the ability to topology optimize your lattice could be used in a lot of different scenarios where you want to remove material, but you also want to impart some other sort of characteristics to your part.
So you're saying it's bigger than implants. We could see latticed parts, lightweight and strong, everywhere.
Yeah, I think that's definitely where we're going. That's it for this episode of the Cool Parts Show. If you have a cool part you'd like to see featured, email us at coolparts@additivemanufacturing.media. Thanks for watching. Don't forget to subscribe.